In this video, we'll have a look at how to use the SQLite database on the Android system using the Room API. So let's just have a quick look at the developer's website. So if you go to developer.android.com, training, data storage, Room, index.html, you'll get to this page that says Room provides an abstraction layer over SQLite to allow fluent database access while harnessing the full power of SQLite. Apps that handle non-trivial amounts of structured data can benefit greatly from persisting that data locally. The most common use case is to cache relevant pieces of data. That way, when the device cannot access the network, the user can still browse that content while they are offline. Any user-initiated content changes are then synced to the server after the device is back online. Because Room takes care of these concerns for you, we highly recommend using Room instead of SQLite. However, if you prefer SQLite APIs directly, there's the link that you can go to. Now, they say there's three major components in Room, and we'll look at that now in Android Studio. There's the database, there's the entity, and the DAO. And you can read a bit more there about the class that needs to have an annotation of @database and @DAO at your DAO level and so forth. So the app uses a Room database to get data access objects or DAOs associated with that database. The app then uses each DAO to get entities from the database and save any changes to those entities back to the database. Finally, the app uses an entity, which will basically just be a table inside of your database and a normal class in Android, to get and set values that correspond to table columns within the database. So you can go through these. You can see also there's some basic Java coding, and you can see how they do this. They will create a normal class, and this becomes your entity with adding the @entity at the front of or at the top of your class. You should have a primary key there, which you'll indicate with an @primary key. And then if you want your column names different or named differently than you have your variable names in the class, you can also add @column_info. Then your user DAO class or your data access object classes look something like this. It's an interface that gets declared, and you'll have the @DAO at the top. And then you can have different queries running and your methods that will basically use these queries to return back data for you or to do something. So we'll have a look at this now. So you can have the @query there that will run a specific query, and you can have the @insert, @delete, and even the @update there. And then also you'll have your app database that will link back to your entities, in this case the user class, and also link back to the user DAO, the one that we did there. So we will quickly have a look at how do we set up these three things: your normal Java class, your interface, which will be your user data access objects, and then your database class that extends the Room database in order to put basically these two together so that we can start working with it. And then ultimately you need a copy of that database, but only one copy of it. And you can see there, if your app runs in a single process, you should follow the singleton design pattern when instantiating an app database object. Each Room database instance is fairly expensive, and you really need access to multiple instances within a single process. So we will have a look also at creating this or using the singleton design pattern in order to get only one copy of our database. Then also, if you go for a hands-on experience with Room, try the Android Room with a View. So if you do not like my video, you can actually go to Android Room with a View, and you can go through every single step. They tell you, if you go next there, you can how to create your app, and if you go on, they say what you need to add and so forth. So very important here, we need to go into our Gradle file and add this implementation. So this will be the first thing we're doing, and that's why I'm linking to this one that says Android Room with a View. And you can see the newest versions currently is 1.1.1. So we're going to implement this now in our Android application. So let's go and create a new Android application and then add this to the Gradle file. Right, back at Android Studio, basically I've just created a new blank project called Room API Video. And then on the main activity, I've added a few components there. So just to save us some time on this video, go and create 3 edit texts there, and you can see I called them ETID, ETTEL, and ETName. So we're going to have an ID, a telephone number, and a name for every contact. And then we're going to have a look at how to create, read, update, and delete using a contact table and changing the data or getting back the data from that contact table. Right, so there you can see there's my linear layer that's vertical. I've got ETID, ETTEL, ETName, BTN create, BTN update, BTN or read, update, and delete. And then I've got TV results where we can show the results. Then go back to the main activity. In the main activity, I've set up all 3 edit texts. I've set up all 3 or 4 buttons. And there you can see there's the find view by IDs as well as the buttons to find them on the layout file. And then for every single one of those 4 buttons, we've got an on-click listener so that we can do something in there. Right, so that's basically it for what I've done so far. So before we do anything else, let's go into our Gradle build.gradle file, or first go to your project level build.gradle file and make sure that under all projects, you've got Google there. So that's very important. It must be there. Now, if you go to your build.gradle module app, let's go and add that from the website here. So just go back to the website, take all of those, copy them, and let's paste them here. Now, instead of room version there, I'm just going to have 1.1.1. I'm going to copy that. Sorry, there we'll have 1.1.1. So I'm going to copy that part and just paste it for these versions. And then make sure you say sync now. Right, so if you know that your build.gradle file is now fine and working and everything compiled correctly, we can start building our Room API database. So let's go into our Java folder. And the first thing I'm going to do here is to just right click and say new package. And we're going to create a new package there. And the package that I want there will be called Room. Let's just call it Room, or you can call it database or whatever you want. So I'm going to place all the database related files inside of this Room package. So right click there again and say new Java class. And let's call this class contact. So you'll see from our main activity that every contact will have an ID, a telephone number, and a name. So let's just quickly create those. So I'll start off with a private long ID. So every contact will have an ID, and then I'll have a private string name, and I'll also have a private string cell phone number. So let's say this is my contact. Now for the Room database or the Room API, we're just going to create the getters and the setters and then use that default constructor to construct the object for us. So with the Room API, just have your values at the top, your properties for your class, and then the rest should be generated. Now this contact class then will become an entity. So you're going to start typing at the top at entity. And this entity will form a table name in my database, and the table name will be contact. So I'm going to call this table the contact table, and it will have the following 3 columns inside of the contact table. It will have a column for ID, for name, and for cell. Now, for one of these, you should put a primary key. So I'm going to have the @ there and indicate that my long ID will actually be my primary key, which will be a unique value in my database. If you want to change the names for every single one of your columns, then you can also go and add an @column info. And now for the column info, you need to specify a name for that new column. So I'm going to name them exactly the same, but just to have a complete example here, you can add these column names and name them something else in your database. So for now, I'm going to keep mine exactly the same. So the long ID will become my primary key, name will stay name, cell will stay cell in your database. So what have we created so far? We've created the contact class, and this contact class becomes now an entity inside of my room database, which means that I will have a table called contact with columns for ID, name, and self. ID will become my primary key, which means every value in the database under this column must be unique. Right, so that was step number 1. Step number 2 is we need to go and create a new Java class again, but this time it's going to be the interface. And we're going to call this one the data access object. So what I normally do is to just call it contact DAO, so the same name as your table, but just add DAO at the end. Right, so now for my contact DAO, this is an interface, not a normal class. At the top of this interface, you need to add @DAO so that your database knows that this is the data access objects inside of here. And now this is actually very easy to do. You can just go and create a few methods there. Let's say, for example, public void insert. And let's say for this insert method, we want to pass in a contact object, and then it should be inserted into the database automatically. So just to be clear here, the public keyword's not needed here. So you can leave this out totally for interfaces. So what we can do then is to not add any access specifier there, because the access specifier will automatically be public. Okay, so now for this method, because we know it's an insert method and it's quite easily inserted into the database if you know it's a contact object, which means it's one row in the database that will consist of an ID, a name, and a cell phone number. So then we can just add the @insert there, and the Room API will automatically know that when you call the insert method, it will insert this contact object into your database. Now let's try something else. We can also have a delete method here. So remember, it's public. So it's going to be public void delete. And let's say we want to pass in, again, a contact object. So now, because this is also straightforward, we can just add delete there, which means that if we call this delete method, passing in a contact, it will go and search for that contact in the database and actually delete it. Right, so insert and delete could be really straightforward in order to update your database by inserting or deleting a new object. Now let's say we wanted to delete, but we want to delete a contact by looking at the ID of that contact. So I can then say void delete and then passing in a long ID. Now, because this is not the same type as the class, if you just say add delete here, it's going to have a problem deleting this. So what we'd rather do here is to run a query. So I'm going to run a query in here, and the query must be in as a string value. So what I'm going to do is to say delete from the contact table where the ID is equal to the ID that was passed into this method. So you can see when I refer to the ID that was passed into the method, it refers to this ID now. So there must be a colon there and then the ID or whatever you call this variable. Now you can see that the spelling of ID there, if I just call it IDs, you'll see it cannot pick it up. So this ID there must be part of your contact class and what you called it or named it there, which means in the database it's called ID. So you can see that ID must be exactly the same spelling as you indicated there. So I'm going to run a query to delete from the contact table where the ID in the contact table is equal to the ID that was passed into this method. So that's a nice query to run a delete looking for something specific. We can do the same delete looking at a name or a cell phone, but remember that somebody or two people could have the same name, maybe not the same cell phone number, but maybe it's the same people or two people in the same household sharing the same cell phone number, then you could also have a problem. So it's then better to delete by the ID. So I can either pass in the whole contact and it will automatically delete it for me, or I can pass in an ID and run a query to delete that specific contact. Now let's look at updating a value in the database. So we can just say void, let's call it update, and then let's just pass in this contact object again. So if we pass in a contact object, it's very easy for the database or the Room API to know what you're doing. So you can just say add update and it will update that specific value for you, the one that you passed in. Right, so we've got create, that's inserting, we've got update and delete, but we still need to do the read part. So how can we read or get something back from the database? So for that, we can run a query again. So let's just add the method. Let's say we want to have a list now of contact objects from your database, and we're going to call it get all contacts. Well, we cannot have the void keyword there because we are returning something. So let's just say Alt Enter on that list. So remember that the word public is actually in front of it. So it looks like this: public, get back a list of contact objects, and we call the method get all contacts. But because it's automatically public, we don't need to add public there. Okay, and then I'm just going to say at query again, because this is not just getting a specific contact. We want to run a query to see what do we want to get from the database or from this table. So I'm going to say select star everything from the contact table, and we can even order it by a specific column. So let's get all the objects from the contact table, but order them by, let's say, the name property or the name column. Right, so this is a query that we can run: select star from contact, order by name, and when we call this method get all contacts, it will run the query, get all the contacts, and then place it into a list of contacts for me. Right, let's try another one. So let's say that we only want to get back one contact, a specific contact, and we want to get back that contact by its ID. So we can say contact, get contact by a ID, and then passing in some sort of ID there. So now we can run a query again, and we can say select again star from your contact table where the ID column is equal to, again, this ID that was passed in, same as what we did there. So now instead of deleting it, we are selecting everything from the contact table where the ID is equal to the ID that was passed in. But because we know the ID is unique, we will actually just get back one contact. Right, so let's just add some space here between the methods so we can clearly see the methods. And that's the methods then that we will use as the contact DAO, or the data access object. So you can add as many insert and delete methods as you like, but your at insert will automatically insert an object of that class, delete will automatically delete an object of that class, and update will automatically update a contact object of that class. For the rest, we can run queries to do what we want to do. So you can add really as many methods as you can think of inside of your contact DAO. Now the last part that we need to set up this room API is to go into room again, say new Java class again, and we're going to create a third class here, and I'm going to call it app database, and this will be my database file. You're going to say okay there, and let's just open it up, and then your app database class needs to extend room database. Now, also very important here, this class must be abstract. So you're going to say abstract class, app database extends room database. Now, at the top of this database, to allow room to work and do its magic, you need to add the @database tag. And inside of this tag, you're going to indicate which are your entities. And your entities in an array, basically, you're going to list your classes or your tables. So it's going to be contact.class, and let's say you've got another class with its contact or with its DAOs, then you can also list it here separated by commas, which means that you can have different tables inside of your database and separating it by commas. So in our example, we only have one. Then you're going to put a comma there. You need to have a version for your database, and we're going to set it as 1, and you need to set the export schema, and we're going to say that one should be false. Now let's go into this class called app database. So very important, at the top you should have @database there, indicating what is the entities or the tables for your specific database. Listed there, also separated by commas. A version of your database, and then setting the export schema to false. Right, and now inside of this class, we're going to have a public abstract method too much space there. So you're going to say public abstract, and then the type of your contact DAO must be returned here. So you can see if you've got your contact DAO called contact DAO, that's exactly what I'm going to return there. And you're going to call get contact DAO. So let's say you had a second class here called person, and then you could have said there person.class also. Won't pick it up because we don't have it. And then you can have a second method here that will get the DAO for that specific class. So you can have more than one table in your database. Right, so in this example of ours, we only need one. So these are the three important parts that you need to have for your Room API to work. You need to have a contact class or some class with any name, but it must be an entity class. So it must have @entity at the top. It must have a primary key, and then you can change the column names. Secondly, you need to have a DAO class, a data access object class, with methods that will have links to insert, delete, queries, and update, so that you can change the data in the database and also get it back. Then thirdly, you need an app database that will take these two classes and bring them together in a database. Now for the last part, before we can start in our main activity to see how this works, we need to have a class that will get us an instance of this database. And you'll remember from the website that they talked about using a singleton. It means that we basically want this database to only exist as one object in memory and do not create different instances of it, because it can be quite expensive on the memory side. So in order to do this, we're going to create a new class inside of Room. So let's go right click, new Java class, and I'm just going to call this connections. You can call it whatever you like, or connection to the database, or whatever you want to do there. So it's a normal class. In this class, I'm going to have two variables that I'm going to declare at the top. I'm going to have private static connections, and I'm going to call this instance. The second one I'm going to have here is to have private app database. Now, where's that one? That's the last thing we created now. It's called app database, so to get a connection to the database. And let's just call it database. Now I will need a private constructor here. So I'm going to say private connections, and I'm going to pass in some sort of context here. And then inside of this connections constructor, we're going to set up our database. So the database will be, and this is how you call it, you're going to go to the Room class. So it's going to be room.databaseBuilder. And you can see the database builder accepts a context, a class, and then a string as the name for the database. So the context will just be the context that was passed in through this constructor. The second argument will be your appdatabase.class name. So that's referring to appdatabase.class there. And then your last one there is the name of your database. So let's just call this one db_contacts. Right, and then there's a few things that we can add here. You can add one dot there, and you can just directly build this. But for this example, we're going to allow main thread queries, and then we build the database. So just to test out all the methods inside of the Room or the contact DAO class that we created or interface, we need to use this allow main thread queries. So in the next video, I'll show you how we can remove this comment or just comment it out there so that we do not use this allow main thread queries. And that's actually how it should be. So using this line of coding there should not be in your final production of your app. We should use the async task to run every single thing in a different thread and not on the main thread. But for now, just to test out everything and to understand it a bit easier, I'm going to allow main thread queries, and then on the next video we will remove this part and we'll see how we can use the async task to work with this database. So for now we keep it there, but we'll change it later on. Right, so this private constructor, now normally we are used to public constructors, so we're going to keep this as a private constructor so that no other class can make another object of this. Okay, so now we're going to go into another method. So we're going to have another method, public static connections, and we're going to call getInstance. And this getInstance method will accept a context, so that we have a context that we can pass into the connections constructor there. And inside of this getInstance method, Now inside of this getInstance method, we're going to use the keyword there, synchronized, and I'm going to explain this now. I'm going to say synchronized, and I'm going to say connections.class. And then let's just open up this with brackets there. Now let's quickly have a look at the synchronized keyword in Java. So the synchronized keyword there, they say, simply put, in a multi-threaded environment, a race condition occurs when two or more threads attempt to update mutable shared data at the same time. So this could be in our database where two different classes try to update the same database at the same time. So Java offers a mechanism to avoid these race conditions by synchronizing threads' access to shared data. A piece of logic marked with synchronized becomes a synchronized block, allowing only one thread to execute at any given time. So next time that a different thread wants to get access to that, it needs to wait in line for that to happen. So if we just go down a bit more, it says when we use synchronized block, internally Java uses a monitor, also known as a monitor lock or intrinsic lock, to provide synchronizations. These monitors are bound to an object. Thus, all synchronized blocks of the same object can have only one thread executing them at the same time. So let's just go back to Android Studio again. So basically what we're doing here is saying that this connections class of ours can only be accessed by one thread at a time, just to make sure that we don't have different threads exactly at the same time trying to change the same things in the database. Okay, so we're going to use synchronize there, and then we're going to test if this instance, so the instance there will currently actually reference null there. So the first time you run this, it will reference null because it's not pointing to anything. So we're testing here if it is still null when we run this for the first time. We will say that instance should be new connection. So now I'm calling the constructor called connections there, and I'm going to pass in the context. So in your get instance, you'll get a context there. We'll look at that now, and that context will be passed in. So now we create a new object of this connections, which will have this database field. Right, so database will then be created, and then we can have an actually just to return the instance there. No need for an else. So only if the instance is currently null, then we're going to make a connection, create a new object which will hold the database as one of its fields. And then we have a new object connected to instance, which is an instance of the database. And then we just return the instance, whether it's null or not. If it's null, we're going to set it and then return it. If it's not null, we just return it. So we're working with the exact same database again. Now, right at the bottom, we will just say public app database and call it get database. And here we'll just say return that database field of ours. So we're going to create a new object or a new instance of it, and that database will be part of that instance. There it gets created in the constructor. And then on this new object called instance there, we can call the get database method to return the database for us. So this is the singleton design pattern to make sure that we only have one instance of the class running at any given time. So we can call getInstance as many times as we like, but actually what will happen is this database will only exist once because we're checking if the instance is null. If it's not null, we just return it. But if it is null, we first make a connection to a new database, running this constructor, we get the connection to the database and we return it. So the next time we run this, the connection is already there, and we just return that connection by using return instance. Right, so now all our setup process for the Room API has been done. We've got the contact class, which will become our table, contact DAO to work on that table. We've got the app database that's got a hold of all our tables, and then connections to get a connection to the database. Now let's go into the main activity and see how we can get this all now to work together. So in my main activity, if you look at the layout file quickly, you will remember that we're going to ask the user for his ID, his telephone number, and his name. And now we want to use this first method to insert a new contact into the database. So how do we do that? So when we click on btn create, Remember that you can now go and test. I'm not going to do that now, to test if every one of those fields is in fact empty or not. So I'm not going to do that with if statements, just to save some time. So we will create a new contact object here. So we will say contact, let's say contact equals new contact. And remember, we are using a default constructor there, which means that we need to set the rest of the fields. So I'm going to say, let's set the ID there. And for the ID, I'm going to use long dot parse long there and get the ID from what the user typed, which means that it's going to go to etid.getText.toString.trim. Now remember, if you open up that file again, that's the ID. So whatever the user types there as a string needs to be converted to a long, which is the ID that we accept there. Our ID must be a long. Right, so we've got contact.setID, that's set. Now let's go to the next one. So we're going to call set, let's say set name. And for the name, that is a string, so we can just directly go to etname.getText.toString.trim. Now the last setter there, we're going to call set cell, and for the cell phone number also just a normal string, so we're going to go to ettel. So remember, we called this one ettel. So we're going to say ettel.getText.toString.trim. So I'm going to use a normal try catch block here to try and catch any type of exception that could occur, and I'm just going to use the normal exception there. And then if we want to catch the exception, then there I'll show the toast just to say something like error and then show e.getMessage to show the error message that occurred. Now inside of this try block is where I actually now want to go and work on my database to add this new contact to the database. So in order to do this, I'm going to declare a contact DAO at the top. So it's going to be an instance of this class. So it's going to be contact DAO. Let's call it contact DAO. And now you remember that in my app database, if I call get contact DAO, I will get basically an instance of that contact DAO. So that's exactly what I want to do now. So somewhere here, I'm going to say contact DAO equals. Now in my connections class is where I get a connection to this database. So I'm going to do the following. I'm going to refer to connections. I'm going to call the getInstance method and pass in the context. Now it's very important here that you do not leak a context here. So this app database or this connections class could be accessed by any number of activities. So it's not good to pass a context in here that refers to an activity. You will leak memory here. If that activity gets closed, or that activity cannot get closed if it's still connected to this open database. So that's very important then here to pass in the application context. Now on this getInstance then, what does getInstance return? getInstance returns an instance of this class, connections. And on this class then, on that object, I can call getDatabase to get my database. So I'm going to say after that one, getDatabase. Now that is the database. So it's an object of this class. It's this class basically, the app database class. And now on this class, I can call getContactDAO. So there, I'm going to call getContactDAO. And now this variable, which is of type ContactDAO, is now a ContactDAO. And I've got a connection to this class or this interface where I can call these methods that will automatically execute the correct thing for me as part of the Room API. So now I can just use one of these methods. I can use insert, delete, update, whatever I want. So in this case, we want to insert a new contact object. So I'm going to say on this contact DAO, if you put the dot there, you can see there's all the methods. I'm just going to call insert and pass in the contact object. And that will insert my contact object to the database. And we can just display a toast there. And we can say successfully created. And that's done. You have added a new object or a new contact to your database. That's all you need to do. Right, so let's go to the read part here and see how we can read something now back from the database. So I'll have a try and a catch block here again, because reading from a database, writing to it, updating could throw an exception. So make sure that you always use your try catch block there. Okay, so now in the catch, let's just do the exception again. So we'll say error e.getMessage. Right, now remember that if I want to try and get something back from the database, let's say we're going to try to get all the contacts, then you can see that it returns a list of contact objects. So let's go back there, and we'll need to have a list here also that can catch that contact object of ours. So I'm going to say list of type of type contact, and we can call this, let's say, contacts. Now let's just import this one, so it's going to be Alt-Enter on it, and we're going to say equals, and now I'm going to refer back to this contact DAO again. So I'm going to say contact DAO dot, and the get all contacts is the first one that pops up as the autocomplete, because it retrieves back a list of contacts, and that's all you need. That will go into your database according to this query that you had there for this method. So it's going to go and say select everything from contact table and order it by the name property 100%, and you'll get all your data sorted there by name inside of this list. Now I'm going to use a string builder class here just to build some sort of a result that we can print out for the user, and I'm going to say results equals new string builder. So this builds a string for me where I can call the append method to add to my string the whole time. So I'm going to use a for loop. Let's start from 0 until I less than contacts.size to run through all of those contacts that came back now with that list and show the results for all of them. Now obviously if you had a recycler view that accepts in the adapter contact objects or a list of contacts, then you could have just passed this in now and then set your recycler view. But for now we're just working with a simple string that we're going to build. So I'm going to start with results.append. So I'm just going to add some string to, or some text to this string builder. So we're going to start off with contacts.getI, and that gets us the object. And let's say we want to call a get name first. So we'll show the guy's name, and then on that results I'm going to append again, and let's just show a comma there with maybe a space. Then again results.append, and what we're going to append here is the second value there, so it's going to be contacts.getI again, .get, let's say, the cell phone number. And then again results.append, and let's add a comma again with a space, and then again results.append contacts.getI again, .get, and in this case the ID. And then just to make sure that we've got everything on a new line, or every new object on a new line, let's just also add the new line character there, so that we know that every time the for loop runs, we're on a new line for the next guy. Right, so these are just another way of using strings. Instead of using one big string with a lot of pluses there, which Android doesn't really like, you can use the string builder class to append. Okay, and then we're going to go to TV results. I don't have a TV results. Let me just have a look at this one quickly. We called it TV results, so maybe I missed it out there at the top. So let's just add it, text view TV results, and let's just link it up quickly. TV results equals find view by ID r.id.tv results. Right, so we've got a link to TV results there, and let's use it. Set text, and the text I want to set here is this results .toString. Right, and that sets my whole result section for me. Right, so before we carry on with the rest of this video, let's run it quickly and see what we've got so far. So I'm going to run it on API 26 there. Right, so now the app is running. Let's see if we can enter an ID here. So I'm going to say, let's say 1001. Enter a telephone number, just any type of telephone number there. Let's say Chuck or Chuck Norris there. And then we're going to say create. And you can see it says it's successfully created. So we basically did this part there where we create a new contact. And now we can read that back to make sure that we have it. So if I click on read, it says Chuck Norris and its values. Now we can add another one there. So let's say 002 and add a few others there. And let's call this one John Rambo. Create, successfully created. Click on read and you can see Chuck Norris now is at the top, John Rambo at the bottom. Let's add a third one there. Let's just add another number there. And we can have this one as Adam Adams. So you agree then that Adam Adams should now be at the top. So if I click on create and then read, it will be sorted at the top. So this now depends on what you say there as your query on how you get it back. We get it sorted by name. Right, so the first two parts working 100%, create and read. Let's look at the update method quickly. So let's say that we want to update an contact by its ID. So I'm going to have a try and a catch block there. And we're going to have exception E there. Show your toast again. And we'll say error E dot get message. Right, so in the try block, what I'm going to do first is to first make sure that that contact which we want to update actually exists. So we're going to say contact equals referring to my contact DAO again and calling get contact by ID. So let's say we want to update a specific contact now. Let's say we want to update Adam Adams and the ID is 1003. So let's say we want to get that and update that specific contact. So now this get contact by ID method is basically this one that we're using when we're passing in along. So we're going to say select star from the contact table where the ID is the ID that we passed through, which means that we're going to get that contact and make sure that there is a contact before we try to update that contact. So what we're going to test here with the if then is to make sure that this contact is null or not null. So if it is null, we can just show a toast message to say the contact does not exist. And then the else part will be the contact exists and we can now make changes to that contact. So I'm going to say contact. Let's say we want to change the name. So we're going to say change name to Adam Peters. And now we've changed or updated this name, but we need to save that change that we made. So let's go back to the contact DAO. And on that contact DAO, you remember that we have an update method that accepts a contact. So let's go back. So we're going to call the update method there, and we're going to pass in this contact, which will change the name for Adam Adams to Adam Peters. And let's just show a toast to the user also. Successfully changed. All right, let's see if this one works. Let's run this one quickly. Right, so let's click on read again, and you can see Adam Adams still there. If I click on update now, we are updating Adam Adams to be Adam Peters, like we said there. So if I read again, 100% changed. Right, let's look at the last one, which is the delete method. Now for this method, I'm going to do some of it the same. So I'm going to copy this whole try catch block there with the update and paste it here. So we're going to go and get the contact by its ID. So let's say we want to delete Adam Adams now, which is now Adam Peters. So we changed that 1003 to Adam Peters. So now if we have Adam Peters then, so we first get or try to get that contact. We have the contact there. Again, check if the contact is null. If it is null, it will say the contact does not exist. So the else part then will be, we will now actually delete this contact. So instead of calling update, we're going to call delete there. Now remember, there's two delete methods. There's a delete method that accepts an ID, and there's a delete method that accepts the whole contact object. So this is up to you. You can either send in this contact that you know now exists, or you can just pass in the 1003, which will also delete that one. And because we are in this else, we know that that contact exists and we can delete it. And now we can just say successfully deleted. It will also be good if you can ask in this else, maybe ask these, are you sure you want to delete this, by using a dialog. Right, so let's see if we can execute this code then and delete a contact. Right, so there the app runs again. Let's click on read. It's still Adam Peters. And now you can see that we're going to get the contact by its ID 1003, which is Adam Peters. And if it exists, we're going to delete it. So let's just click on delete, successfully deleted. Click on read again. Now it's gone from my database. Now let's just quickly go back to this app database, or not to connections. And you remember that we added this one line there that says allow main thread queries. So if I comment out that one line, what will happen then? So let's run this quickly again and see what happens when we run this. Right, so let's just click on read again, and you can see that it says there's an error now. Cannot access database on the main thread since it may potentially lock the UI for a long period of time. And any one of these buttons that you try to click now will actually do the same thing. So when you send out your application now in production, you may not use this one line there. So it must be gone, which means that we should do this another way to make sure that everything is not run directly on the user interface thread. And for that, we'll use the async task. So I'll see you in the next video where we'll look at how to implement the async task with the Room API.